Hey class, Mr. Moyden here with another example to help you prepare for your last finance assessments. This one deals with present and future value regarding annuities. Remember, an annuity is any kind of financial transaction that involves regular payments or withdrawals over a period of time. So if you're putting in or taking out a fixed amount of money every month, every year, or what have you, but you're putting in more than once or taking out more than once regularly, then that's an annuity. So let's take a look at this problem. It says your retirement account at work earns a 15% interest rate. That's quite generous. If you hope to live for 23 years off your savings, after retirement by withdrawing $3,000 a month from this account, how much should be there when you retire? So once you have your retirement party, you figure 23 years is a pretty nice retirement. And the thing is, we want to extract this much every single month. And the question is, how much should we have so that we can have enough to spend over those 23 years? So whenever you're withdrawing money, it's a pretty dead giveaway that this is probably going to be a present value problem. So this word keys you in to present value. How much do I need to have upon retirement in order for me to then take out money, right? Month by month by month. Because if I have nothing in the account, then as soon as I try to withdraw some, of course, I'll overdraft. So the present value formula is V is equal to P. 1 minus 1 plus I to the negative n over I. Let's list off what these things actually mean. P is equal to the withdrawal size, how much we're taking out per month. I is the period interest rate, and N is the number of withdrawals. So let's see what we have here. We're taking out $3,000 a month, so this is going to be 3,000. Our interest rate per year, in general, whenever you're given an interest rate, it's an annual interest rate, is 15%, which is 0.15. So the rate is 15%, but the period interest rate is divided by 12 months in a year. So 15% every year, how much is that per month? Because I'm taking money out per month. It's 0.15 divided by 12, which, let me do this off to the side here, is 0.0125. So our period interest rate right here and right here is 0.0125. N is the number of withdrawals. So here we got to be careful. A lot of people will mistakenly call it 12 because it's 12 months in a year. Maybe it's 23 because that's another number in the problem. It's kind of both. It's the number of monthly withdrawals I'll be able to enjoy in this retirement. So that's 12 months a year, or 12 withdrawals a year. For how long? For 23 years of happy retirement. So 12 times 23 will give us the actual N value, which is 276. So N is going to be 276. So let's plug all these in. The present value is going to be $3,000. That's the withdrawal size. 1 minus, I'm going to go ahead and add these together just because 1 plus a decimal is just 1 point to that decimal, right? 1.0125 raised to the negative 276. And all of that over the period interest rate, 0.0125. So the hard work is coming up with everything. Once you have that done, if you're careful about how you type it in the calculator, you should be able to find a number. Now, keep in mind, this final answer should be big because you have a big nest egg to then enjoy in retirement. Of course, it shouldn't be astronomically large, but it should be pretty sizable, right? So let's see. I like to focus on the complicated part of the problem first, which is the inside part here, and then kind of work my way out. So let's see, I have, try to make sure you can see this, 1.0125 raised to the negative 276. Okay, that's this business. 1 minus that answer, second negative, the answer button. that's the numerator, divided by 0.0125. And what you should get is 77.405. That's all this business here becomes 77.405. I'm only writing a couple digits down because I'm just going to use this exact value, because the next step says to multiply by 3,000. And you have, as promised, a pretty big number, but you know, retirement, you need to have money saved away to enjoy it over a long period of time when you're not working. $232,216 and the all-important 37 cents. So if you have this much money upon retirement, that means you can take out $3,000 every single month for the next 23 years while earning 15% on the part that stays in there. And you can then, by the time you're done, of course, have nothing left, which means you've been able to spend all of your retirement. So this is the present value based on these deposits. With these withdrawals. The second part of the problem sort of establishes where this amount comes from, because you don't just put all this money in at once. You put it in over time, right? You put a little bit away every single month, and you eventually can retire on that amount. So if retirement is currently 28 years from now, just for example, then how much should you deposit each month into your account to achieve this present value upon retirement? So to have this in 28 years, how much should we put into this account bit by bit by bit in order to accumulate that? Once again, the keyword here is deposits. Deposit clues us into what we're dealing with. So deposit tells us that we're going to be dealing most likely with a future value problem. By putting in money now, how much will we don't know how much I'm going to have in the future. The question is, how much do I need to put in order to achieve this value in the future? So it's a future value problem, the formula for which is A equals P 1 plus I to the n minus 1 over I. I is exactly the same, n is exactly the same, P and A are new. So from the last part, we had I equal to 0.0125. Once again, that was from earlier in the problem. I think I said n was exactly the same. I misspoke there. Let me apologize for that. N is based on the same idea. It's simply not the exact same number. So let me clarify what I mean. In the previous problem, we were living for 23 years and 12 months in a year gives us 276 withdrawals. Here, I'm planning on saving for a slightly different period of time, 28 years, but I'm still putting money in 12 times a year every month, right? So 12 times 28 will give me a slightly different number of deposits. So 12 times 28. I'm putting in money 336 times over the course of the rest of my career in order to then have a nice retirement amount. So sorry, n is a different number, but based in the same basic concept. The number of monthly deposits based on 28 years. The amount that we want to accumulate is going to be the answer from the last problem. And the question is, what is the deposit size? So P in the future value problems is the deposit size. So let's go ahead and plug these numbers in. Let's see, we got 232, 216, 37. That is equal to a bunch of deposits all added together, which is where all this multiplication and exponentiation comes from. 1 plus 0.0125. Let me write slightly larger, depending on how high resolution our YouTube stream is. I'm going to go ahead and add these together like in the last problem. 1.0125 raised to the 336th power. So a bunch of deposits sort of accumulating. Minus 1 all over 0.0125. Okay. So a little cumbersome here. It's not quite as straightforward as the last problem in that we have a little bit of algebra to do even after coming up with our numbers. But do notice that all of this section here is one big numerical mess, which means we can simplify into a secondary number. So let's see what that number is. 1.0125 raised to the 336 is this part. Take away the 1 divided by the period interest rate, 0.0125. gives me this amount right here, 5117.813, etc. So 5117.81 and some crumbs. All of that is times my deposit, which we don't yet know, and that's going to equal 232, 216, 37. So to get PL by itself, to get the deposit size, simply divide both sides by this amount, which again, I'm just sort of abbreviating the actual amounts in the calculator, which we're about to return to for the triumphant finale. Oops, 813. Okay, so let's see, we got 232, 216, 37. That's the amount I want to have. Divided up into 5117. Actually, let me just use the previous answer as promised. Second answer gives me a deposit size of $45.37 a month. This should not be a ginormous number, right? Maybe it's, I mean, this is fairly small, but you know, maybe a couple $100 shouldn't be huge, right? Because you're putting money away every single month. Most of us don't have room in our budget for putting away $30,000 every month, right? But putting away $45 a month over time, over a long period of time, 28 years, slowly accumulates into a very large amount, right? Now keep in mind, I did say that 15% is a pretty generous interest rate. It is. I don't think my retirement fund earns that amount. By the same token, 45 is a pretty small amount to put in every month. Most people put in a bit more than that. But if you are lucky enough to have this kind of interest rate, you can accumulate a lot of money over a long period of time. So some key takeaways, of course, figuring out which formula to use. That's, in a sense, a bit of a vocabulary question, deposit versus withdrawal. And also being careful about what I and N represent and putting your values in the right place. That's what a lot of these financial problems deal with. Alrighty, hope this helps.